it was very interesting. And now we can move to the last presenter of today. Presenting Scanfume, we have Maria Swartling. So if you can...
Yeah.
So we see your screen now.
Yes, can you see now?
Yes, we have it full screen, so it's perfect. So the floor is yours, Maria.
Thank you, thank you. Well, thank you for the invitation to participate here. And as Karin just said in her presentation, I'm very happy to see all the initiatives and ongoing projects in this matter. I am going to present the arc fume technology and what I would like to say, how to turn waste into value, or to be more specific, maybe how to turn the byproduct into value by thermal treatment. I will present a technology that has been demonstrated in the project that is financed by Avfall Sverige, which is a Swedish waste management and recycling association, also ScanArc and several companies from the Swedish energy sector. And among those, I would like to mention SysAV in Malmö, Skåne, who has made a great contribution to this project. ScanArc Plasma Technologies, we are a provider of plasma solutions. Our mission is to deliver heat where it matters. And we have an ambition to participate in electrify industries. And what you can see here are 6 examples of industries where our technology can make a difference. And all these industries require in some way hot gases, and most of them would like to make a shift from using fossil fuels to electricity to generate those gases. I will present the technology more later. One part of what we do is to develop and deliver metallurgical processes, and me myself is a metallurgist by training. So my sort of area of expertise in this matter is that I develop the actual metallurgical process. My company has a very long history starting in the 70s, and what you see here above is a photo from the early 90s, and below is from a couple of years ago. So apart from developing plasma systems, we also have 30 years of experience from this metallurgical process development. What you actually see in the upper picture and the lower picture is molten fly ashes from waste incineration. So as I think Karin and some others also mentioned, is that this some technologies has been around for quite a long time, but maybe it's time now for them to be implemented for real in the industry. We develop processes to melt materials and treat them in molten form, and we usually focus on industrial waste and byproducts. And that is because industrial byproducts most often contain metals that we can extract and recycle. What we do then is to deliver tailor-made technology solutions to industry, which is hardware and thermal units. And what you see in this picture is a pilot plant where we do hands-on development. You can see sort of in the middle right, maybe in the picture, a pilot plant reactor where we can test materials and evaluate how we most successfully would treat them. Since I have a Norwegian audience, I will present a picture of the beautiful city Høyanger in Norway, where you at the sea level see an industrial site. And we have delivered the core equipment to a factory that is treating leach residues from zinc industry. And that is the same type of process that I will present to you. And as I said, I may speak to a Norwegian audience. You may know that this site, which is Nystra Høyanger, has just entered the maintenance mode, and they will soon stop its production. But yet, if I just stick to the technology principles, they are the same for the technology I will present to you and the factory here on this. This is the reference size for the technology I will present. As I said, this factory treats leach residues from zinc industry. And for me as a metallurgist, once I have the leach residue in molten form or I have the fly ash in molten form, for me, I can treat them as the same material. They are equally, for me, they are very similar to each other. once they are molten, of course. Historically, we have been working with byproducts from metallurgical industries mentioned, and it's very easy to understand that me as a metallurgist like to work with other metallurgists. But since a couple of years ago, we started talking to the Swedish Waste Management and Recycling Association and the Swedish energy sector what we can do with the fly ash from waste incineration. And we presented this Scanfume process that we can melt fly ash, we can extract metals, and we can solidify the remaining to a glassy material. And that means that we can turn the familiar ash into this more glassy stone fraction. Since we were now talking to each other from different industrial sectors, and we were talking about the material, about the process that would create a new type of material, we always end up in a quite obvious question. What can we do with this glassy material? So if I have a process that can produce the material, we still need to talk about what can we do with it. And to provide some answers and to build bridges between the different competences, we have over the last year conducted a couple of test and demonstration projects. Let me briefly now finally present the technology. This is an overview of the thermal reactor, and at the top of it, we add raw material to the reactor directly down to a molten bath. The process is continuous, so we have a constant molten bath and we have a constant feeding of new material, fly ashes. The fly ash melts and we use all the degrees of freedoms that we have available, which is the change in pressure, temperature, atmosphere, chemical components, etc., to achieve the reactions that we require to extract metals. What you see down below the box at the right bottom part of the reactor is a plasma generator, and that is a way to convert electric energy to an extremely hot gas. Inside the reactor, we use electricity, as said. Inside this reactor, a plasma flash is generated, and we inject gas, which is then heated up by this plasma flash and flows through the plasma generator and goes into the molten bath under a very high flow rate. The gas that leaves the plasma generator has a temperature of up to 5,000 degrees. So it's a lot of energy in a quite small amount of gas volume. As said, this is a way to create a hot gas from air and electricity without involving combustion reactions or fossil fuels. And then, of course, best case would be if the electricity would come from a sustainable source and not carbon. What you see, I hope it works here. This is a modeling work from a PhD student that we had at the Swedish Royal Institute of Technology. And what I want you to see here is the stirring activity inside the reactor. That is a quite heavy stirring between the gas enters the slag bath and it creates this very intense stirring. And when this very hot bubble meets the liquid, all the thermodynamics and kinetics meet to extract metals. So going back to the overview of the process, what about the fly ash then? Well, it goes in at the top here and it falls down to the molten bath. We don't use only fly ash because it has most often a very high content of lime, which is, we would like to have the ratio between lime and silica in more silica than what is usually the content in the fly ash. Because if you want to create this glassy fraction of the solidified material, we need a little bit more silica, and also we want to have a better flowing slag. It would be too. It's called less viscous or more viscous. Energy is then supplied at the bottom, where we inject. We use electricity. We inject gas. And then we inject the hot gas here at the bottom. Some of the metals that we now have in this molten bath, they have a tendency to fume at a very high temperature, and zinc and lead are among those. And now for some reason I have also used indium and germanium, which may not be present in the fly ash. But these are metals, along with silver, I could also have included, that behave equally under these circumstances, that when they are exposed to this very high temperature and the atmosphere that we create, these will fume and evaporate, and we collect them in a filter. So these metals are concentrated in a filter product, and with the very high concentrations of these metals, this is a valuable product with an existing market, just as Karin talked about in her presentation. We can extract at least 90% of the zinc and 95% of the lead, and it depends on the ingoing content in the fly ash. The more metals in the ingoing content, the more sort of driving force we have to use, or the more the driving force is stronger to extract the metals. And when we have done this, what is left, we tap the furnace and we let it solidify, and we then have this glassy material. So we took these glassy materials and we asked ourselves the question, can fly ash, which is classified as a hazardous waste, be treated with vitrification and reclassified as a non-hazardous waste? And can we then recycle it for construction purposes? Well, this is where I had this great contribution from the energy sector representatives, and especially SYSAV. We made an evaluation of these environmental properties, and we showed that this vitrified fly ash can most likely be classified as a non-hazardous waste. I say most likely because a formal classification was not carried out. And also there, a challenge, as Karin also said, the actual classification is not very easy to address. But we had to make some assumptions, and we can say, yes, most likely we can classify it as a non-hazardous waste. We also compared to some limits for use in, for example, road constructions, and we found a potential to use it for such purposes. However, this was the first study, and we recommend definitely to make a deeper investigation of these geotechnical properties of the material, and to make, of course, a formal classification of it. But we should also keep in mind, let me say first that this is a Swedish report, but you can find all the analysis and all the comparison to limits of how to use it, etc. And it's in Swedish, but it has an English summary in the beginning. We should also keep in mind that we have this advantage position as many other projects that has been presented. We can still design the process, we can still add other materials, slag forming materials to the fly ash. We can adjust the final composition, we can adjust the properties and the geotechnical properties of these materials, and we can also find an application of it before we take a step towards an industrial unit. And last, I would like to show two examples of roads that has been built by byproducts from nearby industries. Both the roads in the pictures have been built by metallurgical slags from steel plants. The upper picture is Åbacka steel plant, which is also where we have our home pilot plant. And the below is the SSAB steel plant that has built this road by using slag from their steel plant and their blast furnace process. And of course, it's my aim and my ambition and hope that treatment of fly ash would also be part of such construction purposes in the future. And that is a quite brief presentation of the technology, and I say thank you for your attention.
Thank you very much, Maria. So we have a little bit of time for questions. So here is one from the audience. What about the electricity input? If you can, you have numbers per ton fly ash, for example.
Yes, we made a project a couple of years ago where we made a brief calculation of that, and I think it was a 9 megawatt installation for a plant that would treat up to between 50 and 100,000 ton fly ash per year. I think if I remember, I can look the real figure up, but I think it was 600 kilowatt hour per ton.
Fly ash.
I think so. Mm.
We have some other questions very specific about the fate of some metals. So maybe you cannot answer there. So I'll suggest to the person asking, but maybe you can say something a little bit about the fate of cadmium and mercury.
Yes, I actually presented that. I had that question last week as well, and I was going to find information about it. I can say that they will also follow the gas streams. They will be removed from the. They will not be staying in the solid material. They in our processes they will evaporate and follow the gas streams, and that is also, of course, why they are in the fly ash from the beginning, because they will evaporate. They will somehow be treated in the off-gas system, and I will be glad to when I upload the presentation to also add a slide about the off-gas treatment.
Good. One last question maybe about energy again, the heat. How is the heat recovery? Do you manage to, I mean, the energy efficiency in general?
Yes, I think we have until now used a wet gas system where we cool the gases, and yes, there is some potential. There is some potential to recover heat, and I think we need to develop that concept as well. Because I know it's a very the topic is very relevant. And maybe we should develop the concept a bit more, and we may not have to. Maybe we don't have to use this wet gas system. We can use a dry gas system and maybe recover heat more.
Yeah, I think for the full scale, good heat integration will be very important in your case. Okay, I think that was the last question we had from the audience. Thank you very much. So now I think we can go to the wrap up. Just let me start. Yes. So we can go to the wrap up. I will not use too much time. I just want to thank again all the presenters and all the participants for their questions. It was really exciting to hear about all these technologies, and I think to see that there is so much actually happening, R&D and erection of plants and projects and people investing so much time, energy and money in that. I think that it shows that this sector can really contribute to the upcoming circular economy. And I think that's a very good thing also, that you have so many people which are both competitors and also propose complementary solutions, so that future customers can have a whole catalog of technologies to choose from, depending on their needs and limitations. So I don't know if you have one last word, Inge. I think now is the time.
Not so much. I also like to thank the speakers and also the participants. We have had up to 120 participants during the webinar.
Yes.
We had some questions in the chat about if the presentations will be made available, and yes, they will. If there are any proprietary material that the presenters don't want to publish, it will be removed. We will also publish the recording from the webinar. This will be available at the Task 36 website, and we will send out an email for all of you that has registered with the information when it's posted. It will be maybe in 1 or 2 days. before it's uploaded.
Yes, the presentation will be in PDF form.
Yeah.
Yes. Okay, thank you very much. And have a nice day or night or afternoon or morning, depending on where you are. And you will hear from us for all the material. Thank you very much. Bye-bye.
Thank you very much. Bye-bye.
Bye.
I think we can go to the wrap-up.